project, and he's going to help us make sense of our real-time data.
Hi. Hopefully people aren't too hungover at this point. Smidge. All right. So, sort of about me. I'm with the HoneyNet project. Been with them, I don't know, 4 or 5 years now. Long enough I can't remember. I have a research interest in, well, data visualization, data distribution, and data processing. Over the years I've collected quite a bunch of data, and just trying to figure out what to do with it and make any sense of it has been, well, interesting and fun. I'm doing data visualization as part of ShmooCon Labs for the past few years, probably 4. And as a day job, I do network security research for a federally funded research and development center. So for those of you who don't know what the HoneyNet project is, the HoneyNet project is a nonprofit computer security research organization founded in 2000 by Lance Spitzler. It's a global membership of volunteers with diverse skill sets and experience. All the tools and research that we do, we make freely available, so people like you can make use of them in your research or your in protecting your networks or however you want to use them. So, what exactly is this talk about? So, with the data visualization work I've done in labs, we've used quite a few different number of tools. We've had luck with some and not so good luck with others. Also, with the amount of people, the amount of traffic happening over this network here, sometimes these tools can get overwhelmed. And so this is sort of going over the lessons learned we've had with actually trying to do data visualization here. And just to preface something, the goal of my data visualization is always to just show the data and to offer awareness to people, to mainly act as a conversation starter so you can teach them more. So, I don't know, how many people here know anything about data visualization? Okay. One thing I bet that I can guarantee just about everyone in here has done at least some form of it. So to start with, we'll go with nice basic stuff. So you get your standard graphs. Bar graphs, line graphs, pie graphs, scatter plots. Odds are everyone in here has done at least one of those at some point. Now we get into more interesting stuff. We've got link graphs. These work really well for showing relationships between two nodes. Though you get a lot of data, it becomes a mess and you can't see anything. And this is where filtering your data down either to a subset or getting rid of noise comes in handy. You get heat maps. The specific example is heat maps with geolocated related data. This is showing senders of spam hitting a particular spam trap. Again, this is something you have to also be careful with this type of map because occasionally this will end up looking like a population map because most places where they have lots of people have lots of computers, and odds are half of them are about infected sending out stuff. Now, data sources. There's a quite different few ways you can get your data to actually generate your graphs or just doing your analysis. In labs, we started with using PCAPs because it's nice, easy to get, and contains a lot of data. But once you get to, I don't know, 2,000 people on the network, yeah, it gets to be about too much data. And the tools start having problems processing it in a timely manner. We started running into a problem with a program called GLTEL, which I'll talk more about later, where we would run the capture and then shut it off, and GLTEL would keep on running for hours and hours and hours. It was that far behind. So last year I started looking into using Bro IDS to help deal with that. How many people in here have used Bro? All right. So Bro does a great job of taking the data stream and summarizing it. It has lots of different protocol decoders and can get you a good amount of information just from that. Yeah, and this also decreases the amount of data that your tools have to actually end up processing in the end, or at least allows you to focus more on specifically what you're looking to get out of them. So, what have we done at ShmooCon over the past years? To start with, we basically used Ether8. Stick a spam port connection into it. We would display source and destination of the traffic and draw a link between them as the communications occur, and then the color of the link would denote what application was used. And the size of the link would be the amount of data transferred. The links would reduce in size over time and eventually disappear depending upon configuration and all that. Now this worked well for a while, but after a few years, as the column got bigger, it wasn't practical. To make this thing even remotely intelligible, you have things up there for maybe 1 or 2 seconds before you have to clear them out because it was just a jumbled mess. You couldn't even make out what IPs were on there. So we then went on to a tool called NetGrok. This came out, I believe this was a Google Summer of Code project. It's actually quite an interesting tool to sort of explain how it works. In the center there's the local system that's actually reading the traffic, and then within the dotted circle are all the systems that are on the local subnet. Outside the dotted circle are all the systems that aren't on the local subnet. And you're able to group the dots on the outside together via CIDR address, which proved to be useful because you can group things like Google, Facebook IP addresses as long as you need the IP space, and just get a general good idea of who was going to. To start with, we were using just a wireless sniffer where the visualization system was set up. Worked well for that. The following year, we hooked it up to the SPAN connection, and it crashed immediately. So either is just, well, we're sending it too much data. Program is written in Java, so. But yeah. So for the past few years, if you've ever been around labs, you've probably seen this. This is GLTAL. So each blob on the screen indicates an event that happens in the logs. And you can define these events based upon the parsers that it uses. It comes with a bunch of parsers for different applications, so like Apache, Ruby on Rails, MySQL, pfSense, bunch of others. This particular graph is visualizing the early stages of like a VoIP attack, actually a VoIP honeypot. And so for ShmooCon, we used the C# parser. And so this, we just spun up T#, had it dump the output to a text file, and GLTEL read it. And as I said, you can run the capture for about an hour. You shut off the capture, and the visualization will keep on going for like the next 3 to 4 hours. So with all that, and I need to slow down because I'm running out of slides, and I'm only 10 minutes in. Yeah. So what's new with data visualization? So originally I was going to actually have what I've been working on running in labs. Unfortunately, laptop I had there wouldn't cooperate, or more like Ruby wouldn't cooperate, and so I couldn't get some of the programs running in time. So you guys get to see here instead. So in the past, we've only used spam ports as our data source. So starting last year, I decided to switch to Bro IDS logs. The goal was to switch over this year. So none of the existing tools we had could understand Bro. And so I had to, well, make new parsers or modify the tools. And so so for GLTEL, I went ahead and made 4 parsers for some of the logs. I made parsers for the log, the connection log, the DNS log, the HTTP log, and the SSL log. And to preface this also, GLTEL does support custom parsers, which is quite handy. It takes a little while to figure out how to do them, but it's not that difficult once you understand the format. So to give you an idea what this looks like now, I'm going to go ahead and show you. And I'm hoping this works because the past few times I've tested this, it crashes about a few seconds in. If it doesn't, I'm going to do it off. So I'm doing this with live con data. So I'm actually going to be connecting to the Bro sensor in the labs and showing you what it sees. If that crashes too often, I'm going to switch over to a local replay of last year's logs. Okay, come on. That's what I want to hang on with that. And yeah. We'll see how long it goes for. So here I have source and destination IPs on each side. That's in the orange and green. I'm showing the what protocol each connection is and what Bro thinks the application is. Then I pull from the HTTP logs what domains people are going to. And then from the SSL logs, I'm pulling out what cipher suite is being selected and what version of SSL is being used. Yeah, I think I'm hitting a bug in NetSSH gem. Now, anyone have any questions at this point? Yeah. Yes, only for the connections. So the source and destination IP, I set it so that So I would set made the parser so to grab the size and represent that with the dot, how big the dot is. Everything else is just, it's arbitrary.
Big data.
Yep.
Could you explain what the length of it is? What it's really looking at as far as the difference between connections?
The difference between like each side, or?
Yeah, each side.
That's just the way I said it. So the difference between each side is that's just the way I configured it.
So other than being fun to look at, what's this tell me?
Occasionally, it can tell you what's making a lot of connections in your network. So like here, if you look at 172.16.7.10, that's the DNS server. So it's good for making correlations between what's talking a lot in your network and so what might be using a lot of bandwidth, are just interesting things to look into. For the most part, I use this just to get people interested and to start a conversation and sort of help for education. I actually, in my replay data set, the DNS servers were so noisy, I had to filter them out, and I had to filter out the vulnerability scanner. So, anything else? Yeah.
Could you run multiple instances of this so that you can filter each one of specific protocols or specific layers of the outside?
Yes. So can I run multiple instances of this to filter multiple protocols, or?
Yes, if you wanted to run one and look at layer 2 traffic and one with layer 3 traffic, or just
Yeah.
could you run like on common operating system?
Yeah. So the question was if I can basically run multiple instances of this at different layers like the OSI layer. As long as you have parsers and a system to gather it, yes, you can. The T-Shark parsers could work for that. Bro, I don't think goes down to the lower levels. So it only goes down as far as 3. And Liam, correct me if I'm wrong on that. All right, good. But yeah, because all this does is just, as long as you have a log file, it can read it. As long as you have a parser that can understand it, it can read it. And the parsers are pretty simple. It's just you specify what each field means, and then you tell it what activity you want to look for. And that when the thing hits that activity filter or command, it will generate a dot. Yep.
Did you find the switch from the keycaps to the bro that you were able to reduce the lag that GLTAG was running into?
For the testing I did, yeah. So, thank you. From switching from PCAPs to using Bro, was I able to reduce the lag that I had noticed previously? And from what I found with the testing I've done at least, yes, I have. Granted, I haven't run it for anywhere near as long as those other ones. I've been able to run my replay stuff for about a half hour to an hour, and as soon as I kill that, GLTEL stops displaying data within about 5 seconds. So really just, it depends on how much data how fast data is being generated. Yes?
My question is two-part. First, do you have any idea what GLTEL is written in? And the second is, how have you experimented scaling GLTEL so that you can get near real-time, as near real-time as possible? Like, what's the most powerful machine you run this on?
All right, so the first question is, do I know what GLTEL is written in? And yes, it's written in Ruby. It is up on GitHub. And what is the most powerful machine I've run this on so that to figure out sort of scale and stuff like that? Unfortunately, right now, the most powerful machine I've run this on is this system right here. Works relatively well until I get a ton of data on here and the frame rate starts dropping. Take what you see on the screen and probably double or triple it. It comes down to how many connections are happening on the network. So like the center section would be filled with dots to like up here. And the frame rate will start dropping. Once the screen clears out, it'll pick back up again.
Do you know where the bottlenecks are?
That particular bottleneck is just in the GPU and the processing. Some of the other bottlenecks I've had is just purely being able to read the logs fast enough. Anything else? Yeah.
So on this, besides looking pretty, I want to get useful information out of the visualization itself. I see the larger circle, what it does represent. I see the funnel at the bottom, that represents the mid-drain connections. How can I use this to interpret what's going on?
So, all right. So the question being, besides it's looking pretty, how can I use this to sort of to actually use this for like a more operational manner, and sort of what does things at the bottom, like the drain at the bottom represent, and the size of the circles represent. So the size of the circles is the amount of data transferred according to Bro. The drain at the bottom is arbitrary. It's just where it drains off the screen. When a dot appears on screen is actually when the connection is, when Bro sees the connection close. At least, yeah. Or and for some of the logs when the actual connection thing happens. For operational, it really depends on what you're looking at and what parsers you're using. If you want to use this on like your web server and have it showing either GET requests, PUT requests, or based upon what errors you're getting, it could be helpful if you start seeing a lot of 404s or yeah, just anything for like forbidden or that type of thing.
Have you played with Logstash and Elasticsearch
Have I played with Logstack, Elasticsearch, and Kibana? Not yet. It's on my list. Yes?
Do you think there would be a way to play with the formatting? I assume there's some sort of compile that you can mess with formatting. That do you think there would be a way to customize the format so that something like a send flood or a particular type of attack would really stand out in that display, or a standard nmask?
So, do I think there's a way to fool with formatting so that things like SID flood or a nmap scan would really stand out? Yes, completely. Because what side stuff's on is completely configurable. I actually just define it in my. Just kill this quickly. That one's probably not a good idea to use. Yeah, I will try to, yes. How's that? Top part's just defining what your logs are. And what color, no, that's just defining what logs are. Yeah, so this, here's where you start specifying which side it goes on, what colors there are, and what actual event you're trying to pull out the parsers. Anything else on GLTL before I move on? All right. All right, now to SkyRails. SkyRails was a program I found about 3-4 years ago during labs. Looks real nice, pain in the ass to work with. I'm not even going to try to pronounce his name. So this was this Yosho's his PhD project. And so what SkyRails does is it visualizes data in 3D space. The camera can move freely throughout the space. Unfortunately, there's no documentation for this program. There's no source code available. And the scripting language is custom. And it's quite hard to understand. So after about a few years, I was able to at least reverse engineer the scripting language to a point where I could actually display stuff.
Excuse me. Have you contacted him and asked for the source code?
Yes, I have. I have contacted the developer. He has said no. I will go more into that later. So I've been able to reverse engineer the scripting language to a point where I can at least display data and do some basic formatting. Work great with static files, so I can make a script to get everything in the right format, dump it into the script into their SkyRails scripting file, and just have it load that static file, and works wonderfully. Found out that SkyRails does have support for external data sources. Unfortunately, like everything else in the program, it is undocumented. Luckily, during ShmooCon last year, I was able to find a script that someone had written to interact with it remotely. And all it really does is gives you a remote console, so you still have to feed commands to it, just like they would be in a static file. And so with that in hand, I went ahead and made a nice Python script to read in the bro data and send it along to SkyRails. All right. Oh, and another unfortunate thing with SkyRails, it only runs in Windows. It does run in Wine and Linux, not always, and it runs well enough. All right, and hopefully this works. There it goes. This is just reading the con log from Bro. Each dot represents a system that's being it's taking part in communication, and the link between them is the arrow for the link between them is just indicating the direction of the communications. There is no, I don't have anything but data sizing or anything like that, and the color is just what I picked. And so right now I have my script reading about 2,000 lines from the log, and it'll sit here and keep on generating them. So I have talked to the author about releasing the source code for this, and his reasoning is that no one uses it, it's such a niche. He just doesn't see a point in releasing it, and if it does become an interest, he might want to continue working on it.
There's no market, but I'm not going to develop a market.
Yes. Yes.
So, along those lines, like for this or the previous one, what significant advantage does this offer over, say, D3 visualizations or something that you would actually use it, or, like you said, he would consider for the developing? So, what's to say, dendrograms or tree maps or you name it, the whole gamut.
All right, let me see if I got the question right. Start from the beginning.
So, what significant advantage, if any, does this or the previous
This one.
visualization have over like any D3 visualization
All right.
out there, like sunburst, dendrograms?
All right, so what significant advantage does this data visualization or the one previously have over things like D3, tree map, and
Yeah, the D3 ones or the Tableau ones.
or D3 tree map, Tableau? I actually have never used them. It's again on my list. I'm still trying to get into this data visualization field. Right now, I'm just dealing with things that look flashy. Because I found that that's at least to the average user, this is much better to get a point across. And things like at least D3 is mainly standard graphs. Is D3 mainly standard graphs?
D3 does everything from your standard bar chart. I mean, it's all open source, it's all JavaScript.
Right.
It's everything from bar charts to fancy stuff like sunburst, zoomable sunburst, tree maps, dendrograms, core diagrams, Voronoi diagrams.
All right. Anything else? All right. Yeah, so that's mainly the reason why I've been using these particular tools, mainly just because they're flashy. There's other ones I've used that are also flashy, but yeah. Jacob.
Okay, so that's obviously an overwhelming amount of data. Can you filter or search through this, like to navigate through the space, or do you just like drift through it and experience it?
Right now, you just drift through it and experience it. To give an example of what this thing can do, let me stop the live data and go to some of the canned scripts. For SkyRails, I'm not sure. The one thing I've noticed with using SkyRails at least is it makes things like scanners really show up like a sore thumb because they just become a bloom, at least if they run fast. I haven't really, so this is actually the first time I've showed SkyRails because I've only got the thing working with Functional Scripts about 4 months ago. For me, SkyRails is just something that looks cool. Throw schmoobles if you like, but to go back with Jacob's question is sort of how to filter down this data. So at least with the pre-canned scripts, it has this little menu down below, which you again have to define the scripting language, and it allows you to define times and stuff. It can be filtered, or you can filter it down with the script you're using to input the data. Yes, Taylor?
Two questions. One is, do the links disappear automatically just stays within the graph?
So, question is whether or not the links disappear after a certain period of time, or once they're made, they stay there. For the stuff I'm using, they stay there until I clear it. It might be possible to get rid of them after a certain period of time. I don't know how to do that yet. Yeah, because at this point I read in 2,000 or end lines, and after it's done, if I have it set up to loop, if I have my script set up to loop, it will send the command to clear the project and then start over again.
Okay, the second question I have is, since there is no documentation for this, and you have spent a considerable amount of time working on reverse engineering and scripting language that was developed for this, have you considered writing any documentation yourself to provide to the community? Just saying.
Yeah, so the question is whether or not, given the amount of time I spent on this reverse engineering it, have I thought about sort of actually documenting it and giving it back to the community? The answer is yes, I have. I haven't done it yet. And so, well, actually gets into my next slide. Sure, I'll just do this. I am going to be releasing all my code. So all the parsers I made, all the and the script I used for SkyRails are all going up in GitHub. They will be in that repository. They're not there yet. The goal is to have them up there probably either tonight or tomorrow. You can get to me through the HoneyNet project. Quite different few methods. All right. Anyone have any questions? Yes.
So, looks like you've been feeding a lot of like real-time raw data.
Yes.
Look into doing any like activation for time series or like summarize data to present a more comprehensive visualization.
I haven't looked at that yet.
Repeat the question.
So, have I looked into taking? I've been looking at mainly using live data. Have I looked at taking aggregate data and doing basically a more comprehensive analysis of the visualization of that? Again, on my list. I don't have a lot of time to do stuff. I wear a lot of hats, but yeah, it's on my list, stuff to do, and sort of in my learning process through data visualization. Anything else? What?
Can you go back to the contact info for the release? There, yeah.
Yes? It's so for GLTL, how extensive is the current parser support? Relatively extensive, and so you can take anything. Most major services, there's a protocol supporter for it. As far as how hard it is to add it, it really depends on what you're trying to get out of it. You can generally look at any of the existing parsers and sort of get an idea of how to add things. So, anything else? All right, and then shameless plug. HoneyNet Project is running a workshop in Norway in May. Interested? Come see us. All right.